Welcome to Quality Branding Hub. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Now, success is all about the project success as well as the people who are working is success in their career also. So it's a blend of activities that is related to concrete, related to quality control, related to construction, and the strategies how we can get the success in the construction. So what is today's topics? Today's topics is all about the again the concrete, because we cannot think our project without the concrete. Now it's not about the concrete but the corrosion of steel. All we know that why the corrosion of steel happening, but today's topics is how we can protect our steel from the corrosion. So stay tuned until then to get the full information, and if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting time, let's jump into the subject. Is corrosion control of rebar. Now it's a problem of every concrete. That's more than the 60% of concrete which is deteriorated or it has destroyed because of the corrosion of the steel. So most common phenomenon, that's the corrosion of the steel, and the corrosion of the steels happen mainly because of chloride and the carbon dioxide. One is called the chloride induced corrosion and another is the carbon induced corrosion. So today I'm not going in that details how the corrosion is actually take place inside the concrete, but today it's all about how we can protect our steel from the corrosion. But before that, we just want to know about the what is corrosion. That is a mainly chloride induced corrosion. Is the more than 60% of the corrosion, or the mainly around 80% corrosion is happening due to the chloride. Now here you can see the chloride, how it is happening or how it causes the corrosion of the steel. Before that, we want to discuss something else. The concrete is this highly alkaline. Its pH is around 12.5 to 13. So this high alkaline, what is happening? This before the above the reinforcement, the oxidized layer is creating, and this passive active oxidized layer helps to protect our concrete from the corrosion. Now if the chloride is coming inside the concrete, now from where the chloride can come, it can come from water, it can come from cement, it can come from aggregate, or it can come from admixture also, or it can come from the environment. So there are sources is available. So if the chloride ion is penetrating inside the concrete, first is what is happening, it's depassivate or breaks this oxidized layer. So when they break this oxidized layer, now the reinforcement is open to the environment. Now what is happening, when there is a oxidized or passive layer, it cannot come to the contact with water or the oxygen, but when this passive layer is break, it is exposed to the moisture as well as the oxygen. So this chlorine is fast breaking the passive layer or the oxidized layer. Now what is happening, if this layer is become unstable or it is deactivated, what is happening, this is a electrochemical process. So due to the potential difference, the you can see here, one part of the rivers become cathode and another part of river become anode. So this electrochemical process is happening. So in anode, what is happening, this iron, it is releasing two electron and it's become Fe plus plus ion. So this Fe plus plus ion, what is, again it is reacting with the hydro which minus ion, and let's see, it is carbon oxygen and the water is coming in here, or the pores, the oxygen water is there, it start reacting and they is producing ferrous hydroxide. Again this ferrous hydroxide with the oxygen and the H2O, or oxygen and the water, it's create the ferric oxide. So in three steps actually it's happening in anode. First it's releasing electron and it's become Fe plus plus ion, and this Fe plus plus ion with the help of Wh minus ion is become ferrous oxide, ferrous hydroxide, and this ferrous hydroxide with the help of oxygen and the water, it's become ferric oxide. And in the cathodic reaction, this electron it's releasing, it's become with again with the help of oxygen and H2, it's become again making the OH minus ion, and again this OH minus is free, so this OH minus again it will start reacting with this Fe plus plus ion, so it's become the chain reaction. So again it's producing the ferric oxide. Now why it is harmful? Because here in the iron and in the three stage it's become ferric oxide. The volume of ferric oxide is exactly 6 times higher than the original iron. So what is happening? This volume is increasing inside the concrete, and the stress is generating, so the crack spalling of the concrete is happening. So two things is happening: this iron, this reinforcement steel is become corroded, this rust is growing, so it is losing its property, and as well as it is destroying the concrete properties. So it is harmful in the both way, is concrete reinforcement as well as the concrete. So we have to protect that one. So in just short, I have just discussed this how this corrosion is happening but due to the chloride, but it's a huge it is a simplified version I have taken, but it has more complicated reaction is happening. Now this one we already know this way this chloride is entering and corrosion is happening. Now how we can, first things, how we can protect our steel from the corrosion. So if we protect the steel from the corrosion, the steel will also not losing its property, and also the concrete will also not get damaged. So first thing is making a ideal concrete. So that is why mix design is important. Thus in the same time the ingredient properties also is important, and the proportion is also important. So just few things: the lowest possible water cement ratio, use supplementary GGBS material or supplementary cementitious material, GGBS fly ash, etc., limiting the maximum cement content, low permeable content, and proper cover. Why? Because see in the reaction what I'm saying, this only possible if there is a presence of water and the oxygen, and from where it will come? It will come from the environment. So if the concrete is low permeable, so it cannot penetrate. So if cannot penetrate, there will be no chemical reaction or the electrochemical reaction, so there will be a less chances of the corrosion. So that is why low permeable concrete and the proper cover is very much important. But at the site, it is most neglected part, that the cover, people are not checking properly the cover, and they're just simply leave it to the carpenter. But it's not like that. You have to check the proper cover for the durability concern, because durability is this thing that how the concrete will withstand over the time period, because we are not making our project for 1 day or 1 year, it's long lasting. So these are the things that the making ideal concrete to prevent the corrosion. But how we can protect our steel itself to make it a corrosion free? First, the metallurgical method, that we can manufacture more corrosion resistant steel. So in the metallurgy we can play with the chemical composition, and we can make the steel which is itself a corrosion protection protective. So the process is there, so we make corrosion resistant steel. So that process is still going on to make more further revision or more prone to protect the concrete corrosion or the corrosion resistance. So this metallurgical method is there. And another is corrosion inhibitor. So this is also a very important part. This is a corrosion inhibitor is a chemical substance added in small quantities to concrete to reduce or slow down the corrosion of steel. So this is another method to make the our corrosion protection. So is a corrosion inhibitor is a chemical. So it is adding inside the concrete to protect the corrosion of the steel. How it is working? See, most common concrete inhibitor is the calcium nitrate. So calcium nitrate corrosion inhibitor is typically supplied liquid form containing around 30% of calcium nitrate solids by weight. Increasing the doses of this inhibitor helps in delaying the initiation of corrosion. In structure exposed to the chloride environment, chloride levels often reach approximately 7 kg per cubic meter. over their service life. Therefore, it is generally recommended not to use the less than 18 liters per cubic meter of calcium nitrate solution to ensure effective corrosion protection. But still, it is a general guidelines. You have to find out the exposure condition, what is the corrosion limit, or what is the chloride concentration on that area, and accordingly you have to do the mix design, and accordingly you have to adjust the doses. It's just an general guidelines. So another method is corrosion inhibitors, that calcium nitrate we are using to protect our seal. It is slowing down the corrosion process. So the next part is coating to reinforcement. So there are different way we can do the coating. First, in derusting, reinforcement bars are first treated with a derusting solution to remove rust. And then immediately after, they are scrubbed using a wet cloth along with cleaning powder. The bars are then washed thoroughly with clean running water and finally allowed to air dry. So derusting also is a process to make our concrete or make our steel corrosion protection. Then phosphating. A phosphate based gel is applied to the reinforcement bar using a fine brush. It is allowed to remain on the surface for about 45 to 60 minutes. After that, the gel is wiped out with a damp cloth. Finally, an inhibitor solution is applied over the treated or the phosphated surface using a brush. Again, we are giving the phosphate based gel, and again we are applying the inhibitor. Again, why the inhibitor? Because it will slow down the corrosion process. Then the cement coating, another way we know, the slurry is prepared by mixing the inhibitor solution. Again, we are adding inhibitor there with the Portland cement and then apply to the reinforcement bar. After the initial coat is cured, a sealing solution is brushed onto the surface, which also provides internal curing benefits. Subsequently, a second layer of the slurry is applied and the bars are left to air dry completely. So this is the process. Then again, the sealing, two coats of sealing solution are applied to the bar order to seal the micro pores in the cement coat and to make it impermeable to corrosive salt. Then fusion bonded epoxy coating that we all know. Then galvanized reinforcement. Galvanized involve immersing steel reinforcement bar in molten zinc, creating a protective zinc coating that adheres to the steel reinforcement. So the galvanized also. So again, it is protecting the reinforcement from the corrosion. So coating of reinforcement, the derusting, phosphating, cement coating, sealing, fusion bonded epoxy coating, and the galvanization reinforcement. So these are the process we can make our reinforcement corrosion less. And another method is cathodic protection. So what is cathodic protection? It's a complex protection system, but it is helpful and useful. So what is that? Cathodic protection involves applying an external electrical current to a system where an electrode is placed on the concrete surface above the reinforcement. So we are applying the external cathodic system. So why? So whatever the ion will produce, it will bring it out. See, the electrodes functions are anode, while the steel reinforcement connected to the negative terminal of DC power source set act as a cathode. In this setup, the external anode gradually corrodes while the reinforcement is still protected from the corrosion. Hence, the term cathodic protection. So, whatever the cathodic ion is there, so that will be taken by the external cathode. So, the main reinforcement will not be corroded. But it has a drawback, that's a high initial cost and long maintenance. So if the Hupsel test it is called, you need to measure the corrosion or the resistance in a periodic way, and it is a high cost. So this is another way, but you need to make this cost, and it has the long maintenance cost. During this process, negatively charged electric chloride ions responsible for breaking down the protective flacellor steel are attracted away from the reinforcement toward the anode. So what is happening? What is the chloride ion? If it is penetrating also, it is taken away from the concrete. So what is, if there is no chloride ion, so passive layer will not break and our reinforcement will be protected. At this anode, these ions undergo oxidation and form the chlorine gas. As a result, the environment around the steel becomes alkaline, again restoring the protective conditions and preventing corrosion. So the cathodic protection is the best way, but is high initial cost and long maintenance is required. So because whatever the chloride ion introduces, it is taken away, and it is what is the reaction that is taken in the outside itself, so that the embedded steel become as no, there is no corrosion. So this is the cathodic protection. And another method is coating to concrete. So acrylic based coating we can make, or any waterproofing concrete. Because see, if we make our concrete waterproof, what will happen? Water will not penetrate, chloride ion will not penetrate. So if there is no water penetration inside the concrete, no reaction will happen. Because is the reaction I have shown you, that with the presence of water and with the presence of oxygen, only this processes happen, the corrosion can happen. But if we protect our concrete water, we can make it waterproof, so that the moisture cannot penetrate or the oxygen cannot penetrate, so the corrosion will not happen. Also the relative humidity, if it is less than 60%, this corrosion will not happen. So it is, or it is normally we are thinking that the chloride only the responsible. No, the ideal condition and the oxygens and the moisture both are equally responsible for the corrosion. But the primary reason is the chlorine or the carbon, but mainly the chloride, which is making this oxidized layer, or is breaking the oxidized layer and make it exposed for the corrosion. So these are all about the how we can protect our steel from the corrosion. And I believe you like it, and if you like it, kindly subscribe my channel and hit the bell icon, so that whenever I upload a new video, you will get immediate notification. And I'm waiting for your valuable comments, so that from your valuable comment everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.